everyone. Today we're talking lesson 8.6, perpendicular and distance. So our objectives are to find the distance between a point and a line and finding the distance between parallel lines. So key concept here, distance between a point, so in this example C, and a line AB. So the distance between a line and a point not on the line is the length of the segment perpendicular to the line from the point. So that distance between C and AB, that's that length of that perpendicular segment. Okay? And then perpendicular postulate, this is 3.6. If given a line and a point not on the line, then there exists exactly one line through the point that is perpendicular to the given line. Because all this is saying is there's only one segment here from C to AB that is perpendicular. Any of these other segments, they're not going to be perpendicular, okay? So the shortest distance between a point and a line is a perpendicular segment through the point to the line. There is only one such segment. That's our summary here. Okay, that's what those last two theorems just told us. Those last two concepts, the postulate. Okay, so distance between points. So here, guys, this is just a reminder of the distance formula. Should be becoming familiar at this point. X2 minus x1 squared plus y2 minus y1 squared, taking the square root of all of that. Alright, so let's practice here. Coordinate geometry. Line L contains points at -5, 3, and 4, -6. Find the distance between line L and point P. Alright, line L and point P. Let's graph line L first. Okay, L contains points at -5, +3. There's one of the points. And 4, -6. Pen's kind of off today, so apologize there. So those are the 2 points on line L. I'm going to use the tool here again to draw my line just so that it looks nice. So from there to there. Alright, get out the line tool here. So there's line L. Find the distance between L and the point P, which is at 2, 4. So here is point P at 2, 4. So what we need a segment that is perpendicular to L. Okay? To find a segment that's perpendicular to L, first we need to find slope of the line. So find slope of L. Slope of L, you guys can do rise over run, you can do slope formula. I'll do the slope formula. So subtracting the y values, -6 minus 3, over subtract the y values, 4 minus -5. So what that's at, -9 over +9. So the slope of line L is -1. Second thing we need to do is find the slope perpendicular to L. So the slope perpendicular to L would be the opposite reciprocal. We've talked about that in lesson 3.3, the opposite reciprocal. So if you thought of -1 as a fraction, you're likely thinking of it as -1 over 1. So flip the fraction, change the sign. That's just going to be a +1. So a slope of +1 is perpendicular to L. So if we're going to draw a segment from P perpendicular to L, we need to use a slope of +1. So go you go up one and right one, or you can go down one, left one. Down one and left one. Until you intersected line L. So this segment, using that slope of, again, 1, the third step here was to draw the perpendicular segment, which we did on the graph. Okay? The intersection of that segment and line L is the point. Where does that segment, where's the segment from P to L that intersects at the point -2, 0. The final step here will be, so if we want to find this distance, I'm going to use blue. If we want to find this distance from P to L, we need to find the distance from that point 2, 4 and that point of intersection -2, 0. So the fifth step is distance formula. So that distance equals, again, you're going to subtract the x values, so 2 minus -2 squared, plus subtract the y values, 4 minus 0 squared. This distance is going to end up being 2 minus 8, so that's +2, or 2 plus 2, so 4 squared is 16, plus 16, so this distance is the square root of 32, which is approximately 5.7. Okay, so that is the distance from P to L. It's quite a few steps, but the steps weren't terribly difficult here, okay? We found the slope of L, so we graphed it, and then we found the slope of L, found the slope perpendicular to it, we drew the perpendicular segment and observed the intersection. Then just really the tougher part was, finding the distance between the intersection and then our point P. Right? So guys, this is a problem you guys can practice if you'd like. Doing all of this, you should be able to find that distance is going to be, the final step is going to be the square root of 20, or that's approximately 4.5. So, graphing it, 1, 2, 5, 4, I'll leave it to you guys. You guys can graph it and find that's the distance. So that's your kind of check there. All right. So distance between parallel lines is the perpendicular distance between one of the lines and any point on the other line. So let's graph and find the slope of one of these lines here. So find the distance between parallel lines L and M with equations y equals 2x plus 1 and y equals 2x minus 3. So graphing them, line L has a y-intercept of 1, slope is 2 over 1. So there's your line L. Line M has a slope, so it has a y-intercept of -3. It has the same slope because they're parallel. So I'll use the line tool and connect all these dots so that we actually have some lines here. Thanks. All over the place here. What happened? All right, so let's get our lines. So line L and line, let's change the color here. Green, just with the dots. There's our two lines. So line L here, line N here. And we want to find the distance between these two lines. So we graph and we find the slope. So first step, the slope of the line L is 2, the slope of the line M is 2. They're the same slope, they're parallel lines. So let's find a slope, just kind of like the last problem. We need a slope that's going to be perpendicular to these two. So again, think of them as a fraction, 2 over 1. Flip the fraction, change the sign. So the slope perpendicular to those would be -1/2, right? So what we need to do from here, we need to connect the lines. Connect lines with a perpendicular segment. So let's start on line L. Let's just choose any point. A point I like, that might be, this point might be a good one here. Starting there at 0, 1, if we use the slope of the slope perpendicular, -1/2, if we go down 1 and over 2, okay, and so now we know that segment there is perpendicular. Well, the intersection of that perpendicular segment and our line, that intersection is occurring at 1.5 and 0. Okay? That's where the intersection is occurring. You can kind of visualize it. It's a little tougher to visualize, but you can visualize. That's where it's intersecting. So the fourth and final step would be to use the distance formula again. So subtracting x values, you've got 1.5 minus 0 squared plus, subtract the y values, 0 minus 1 squared. And of course, having a scientific calculator is handy here. So 1.5 squared, it's going to be 2.25. Plus, well, -1 squared is 1. So the square root of 3.25. And we get this distance is approximately 1.8. All right? So those 4 steps there will find you the distance between parallel lines. All right. The last problem, very similar here. Finding the distance between the parallel lines R and S. Well, these ones are already graphed. Okay. The equations are given to you. So first step, finding the slope of R. Well, that's -3. It's in the equation there. The slope of S, -3. So the slope perpendicular to those would be, flip the fraction, change the sign, 1/3. And so you just have to pick a good point on one of the lines. I'm thinking there on line R. That's the point -2, 1. And you just go up 1 over 3. And you might have to go, up 1 over 3 so that you can see kind of where these are intersecting. So there's about the best spot where they intersect. That was connect with that perpendicular segment. And now we're finding the distance, but to do that we got to find the point there. So that point would be 2 1/3 or 2.3 and -1. So you'd find the distance between those two points. Yikes, yikes, yikes. Guys, late in the day here. That is not the point -2, 1. I'm looking like an Algebra 1 student at this point. Okay. that is the point -1, -2. I have lost my mind. I apologize, guys. This point is accurate. I don't know what got into me there at the beginning. Apologies. So those are the 2 points you're going to find the distance between. And I'll plug them into the distance formula. Get your answer. All right. Your homework is that worksheet that I passed out in class this week. It is also, you can find a PDF copy of it here in the module if you have lost your worksheet. Best of luck. Enjoy the weekend, guys. And we'll see you on Monday.